Hello, this is Britt Kessel with another example video. In today's video, I'm covering example 5 from section 6-4 in the SavvasRealize Algebra 1 textbook. The goal of this video is to apply the recursive and explicit formulas. Alright, so it says the number of people attending the annual Town International Food Festival has decreased by 20% each year since the first year. And so the first part of it is they want us to apply the recursive formula. Alright, so now recall the recursive formula comes kind of in two parts, right? So we have this formula here that says to find this term, you take the common ratio and multiply it times the previous term, and then you say wherever you started out at, right? You need to state what a sub 1 is. Okay, that's what the recursive formula is. And so we're going to start with that. So my first goal here with the recursive formula is to find what my common ratio is and what my initial amount is. So in this case, my common ratio is going to be how many people are attending that year by percentage. Okay, so you guys might recognize that this is an exponential decay function. So my common ratio is equal to 1 minus 20%, which is 0.8. Okay, if I used 0.2 as my R, what that's saying is that only 20% attend each year, but it's decreasing by 20%. So that's why I have to subtract 1 minus 0.2 there. So now that I've done that, now I need to identify my a sub 1, or my initial starting value. And they actually give you a little poster that tells you how many attended last year. So my a sub 1 is 1250. So now I have everything that I need to write my formula. Alright, so here we go. So my recursive formula, I say a sub n equals my common ratio, which is 0.8, times a sub n minus 1. And then remember, you have to say where you start at, so that's where I'm listing off the 1250. Now recognize, guys, that's a number 1, that's not a comma. So some students might struggle with putting things into Savvas because they think those are that's a comma, and it's not. Okay, so now let's go on to the explicit formula. Alright, so the explicit formula says if the trend continues, what is the attendance going to be in 10 years? Okay, so this is asking us to find a sub 10. So I could go through using this recursive formula, and I can apply it 10 times in a row if I really wanted to. But that's kind of annoying, right? That's a lot of effort. So instead, what I'm going to do is I'm going to use the information I've already found, and I'm going to change this to an explicit formula. And that explicit formula is what I'm going to use to find a sub 10. So my explicit formula, I already know my A1, that's 1250, and I already know my R is 0.8, so I can just write that formula right away. Okay, so there's our formula. So now to find a sub 10, where the n is, I'm going to replace it with a 10. So I have 1250 times 0.8 to the 10 minus 1. And I know what 10 minus 1 is, right? I could just do that right away. And so when I go into Desmos, that's what I'm going to do is 1250 times 0.8 to the 9th. And so since I'm looking at the number of people, I'm going to round that to a whole person because having a decimal doesn't really make sense. So I'm going to say about 168 people. And remember, when you use about, you want to use the weird little squiggly equals. All right. Now on this one gives us a formula. Now recognize this is a recursive formula. And you know it's a recursive formula because it has the n-1 notation here, but it also states an initial value. Okay, so this is the recursive formula. And so they want us to write the explicit formula. So remember, our recursive formula has kind of built in our r and our a sub 1. So my rate, my common ratio, is the number in front of the parentheses. So in this case, my common ratio is 1.5, and my a sub 1 is 40, because that's our starting amount. Now when I go to move into the explicit formula, all right, I'm going to have a sub 1 times r and raise it to the n-1 power. Okay, so a sub n equals my a sub 1, so 40, times my ratio here to the n-1 power. So now that is my explicit formula. So then they're asking us to use this explicit formula to find the fifth term. So where the n's are, I'm now replacing them with the number 5. And I'm just cleaning up that exponent a little bit. So 5 minus 1 is 4. So when I go into Desmos, I'm going to do 40 times 1.5 to the 4th. And that gets me 202.5. Alrighty, so there we have it, y'all. That is how to apply the recursive and explicit formulas. Until next time.